First of all, let's take a look at the outline of this lesson. We will begin by defining certain important terms. Adsorption and pressure swing adsorption. Next up, we will delve into the theory behind pressure swing adsorption. Afterwards, we will take a look at some applications of the process. To start everything, what is adsorption? Adsorption is simply the adhesion of fluids, that is gases and liquids, onto the surface of solid materials. These solid materials are called adsorbents while the fluids are called adsorbents. Examples of these adsorbents include zeolite and activated charcoal. Each solid material has properties which determine which molecules it selectively adsorbs. On the next slide is the chemistry behind adsorption. Chemistry behind adsorption. Van der Waal forces and electrostatic interactions determine which adsorbent is preferentially adsorbed. Zeolite, for instance, adsorbs polar molecules better than nonpolar ones, while activated charcoal, on the other hand, does the opposite since it is nonpolar. Let's move on to the subject of the day, pressure swing adsorption. Just like adsorption, pressure swing adsorption is used to separate gases. By applying pressure on the mixture of gases, this ensures that molecules which are likely to be adsorbed by the adsorbent get more adsorbed as the pressure increases. We will learn more about how pressure affects adsorption in the next slide. PSA exploits the principle that gases can be selectively adsorbed by varying pressure. The Langmuir isotherms principles helps us to determine the relationship between pressure and the number of molecules adsorbed on the solid material. The key takes from this principle are: firstly, at low pressures, adsorption increases linearly with pressure. Secondly, there's a point where the solid material becomes saturated at very high pressures and the adsorbed molecule would need to be released by decreasing the pressure. Let's take a look at graph to make it easier to grasp this relation. The y-axis shows the number of molecules of adsorbate, the x-axis shows the pressure of the system. So as you can clearly see, as pressure is increased, the number of molecules also increases until a point it becomes constant, that is the saturation point. This theory clearly helps us to understand the pressure swing adsorption process. This is a vital equation found by the Langmuir principle. We've learnt a lot about the PSA process. Glad you made it this far. The last thing to speak about is some applications of the PSA process. Pressure swing adsorption oxygen plant. The main applications of PSA include oxygen generation. A pressure swing adsorption oxygen plant makes high-purity oxygen for medical and industrial use. It is on which hospitals depend to ensure an uninterrupted supply of oxygen. PSA can also be used in the removal of carbon dioxide from gas streams in industries. Thank you for being with us throughout this educative session.